Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.88. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is always equal to the product of current through this resistance and the value of resistance itself. Now move towards the problem. Exercise problem number 2.88. Find the value of voltage Vs in given below figure if voltage V1 is 12 volt. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage Vs. While one condition is given, voltage across this 4 kilo ohm resistance is labeled as V1 and the value of V1 is 12 volt. First, we have to simplify this network. In order to do that, we will simplify the network from this end. These two resistances are connected in series connection. We can find their equivalent resistance by adding the values of both resistances together and replace that equivalent resistance with these two resistances. Their sum will be equal to 4 kilo ohm. So modify the network by replacing these two resistances with a single resistance of 4 kilo ohm. Now these two resistances are converted into parallel connection and both have same values. Their equivalent resistance will be calculated by dividing the value of a single resistance with the number of resistances connected in parallel connection. In this case, R equivalent will be equal to 4 kilo ohm divided by the number of parallel resistances, that is 2. 4 kilo ohm divided by 2. R equivalent will be equal to 2 kilo ohm. We will modify the network by replacing these two resistances with a single resistance having the value of 2 kilo ohm. Now we will try to find out current through this 4 kilo ohm resistance because voltage across this resistance is given, that is 12 volt, and the value of resistance is also given. So current through this resistance will be 12 volt divided by 4 kilo ohm. It will become 3 milliampere. 3 milliampere current will be flowing from this 4 kilo ohm resistance and the direction of current will be clockwise direction, entering from positive terminal and leaving from negative terminal in order to make this polarity notation across this 4 kilo ohm resistance. So the direction of current through this 4 kilo ohm resistance will be clockwise direction and this same 3 milliampere current with same direction will also be flowing from this 2 kilo ohm resistance because of series connection. So according to the direction of current, polarity notation across this 2 kilo ohm resistance will be current entering terminal will be taken with positive sign and current leaving terminal will be taken with negative sign. Now we will try to find out voltage across this 2 kilo ohm resistance, that will be the product of current through it and the value of resistance. Current through this resistance is 3 milliampere and the value of resistance is 2 kilo ohm. So voltage across this 2 kilo ohm resistance will be 6 volt. Modify the network by indicating voltage across these two resistances. Voltage across this resistance is 6 volt and across this resistance is 12 volt. Now because of series connection, these both voltage values will be adding together. Their sum will be equal to 18 volt and this 18 volt will be appearing across this 6 kilo ohm resistance because of parallel connection. We will assume that voltage across this 6 kilo ohm resistance is V and V will be equal to the sum of both voltage 12 volt and 6 volt. It will be equal to 18 volt. So voltage across 6 kilo ohm resistance will be equal to 18 volt. Now we can calculate through this 6 kilo ohm resistance because voltage across it is known, value of resistance is already given. So current through this resistance will be equal to 18 volt divided by 6 kilo ohm. It will become 3 milliampere. So 3 milliampere current will be flowing from this 6 kilo ohm resistance and the direction of current will be downward. Modify the network. Now we know the value of current through these branches and both currents are leaving from this node. So the current through this branch will be equal to the sum of both currents. Current through this branch will be equal to 6 milliampere. Now current through this 2 kilo ohm resistance is calculated, that is 6 milliampere. So voltage across this 2 kilo ohm resistance will be the product of current through it, that is 6 milliampere, and the value of resistance, that is 2 kilo ohm. Take the product of 6 milliampere and 2 kilo ohm, it will become 12 volt. 12 volt will be appearing across this 2 kilo ohm resistance. And the polarity of voltage will be positive terminal here and negative terminal here because the direction of current is clockwise direction. Current entering terminal will be positive and current leaving terminal will be negative. Modify the network. Now we have the value of voltage across this 2 kilo ohm resistance and this 6 kilo ohm resistance. We can apply Kirchoff's voltage law inside this closed loop to calculate voltage across this voltage source labeled as V. For that purpose, we have assumed the direction of current clockwise direction. Write KVL equation. Start from here. Current entering terminal is positive, so 12 volt will be taken with positive sign. Next, current entering terminal is positive, so 18 volt will be taken with positive sign. Next is voltage source. Current entering terminal is negative, so voltage across this voltage source that is labeled as Vs will be taken with negative sign. Now place this minus Vs on the other hand side of equal. It will become plus Vs and add these constants together. Their sum will be equal to Vs, that is 30 volt. So the value of Vs inside this network is 30 volt. So this was exercise problem number 2.88. Thank you. See you again in next video.